Hi, everyone. My name is Jeff Pollock from Oracle. I'm Vice President of Products. I'm here today to talk about event-driven architecture and data fabric. Really want to do a quick presentation here on how to leverage EDA in order to modernize your data architecture. So let's go ahead and jump right in. The imperative for data across the industry is kind of undeniable over the last few years. We've all seen this happening within our own companies, organizations, even in our daily and family lives. Just the role and the impact of artificial intelligence, the impact of data analytics across our organizations, and really the size of the market. Again, undeniable changes happening in the way organizations and really everyone is utilizing data these days. But analytics, and particularly working with AI for data analytics, is incredibly hard. What we've seen over the last several years is it's been very challenging for most organizations to hit the return on investment objectives that they've got for their organizations, and really the incredible amount of spend that's happening around uptake for data analytics software and really the tools and technologies around integrating data. It's been challenging to sort of get I would say fulfill the promise of data analytics and artificial intelligence. And, that's really what we're going to be talking about today is how to leverage event-driven architecture and data fabrics in order to drive the type of benefits that we all want to see out of these modernization initiatives. So, what the data is telling us across the industry, the analysts that cover the space around data analytic platforms, data fabric, data mesh technologies, even event-driven architecture, is that there's a wave of new technologies that are being brought to bear today in order to really improve the data architecture of organizations, whether that's large enterprises, medium-sized businesses, or even small businesses. There's a couple of big shifts happening. One is, of course, as everybody attending this event knows, we're seeing the industry shift towards these event-driven architectures. We're seeing the rise of real-time data become more and more important within these systems and architectures that we're deploying for data. The other big thing that we're seeing is that multi-cloud deployments for data are really becoming the dominant model for data management. What used to be maybe 5 or 7 years ago, kind of more of a niche solution set, we're seeing more and more organizations, either by design or by strategy, or also sometimes by accident, deploying large-scale data management infrastructure across multiple clouds and on-premises environment. And that's really affecting the way that we design and architect our data-driven solutions, especially for analytics. And then finally, we're starting to hear more and more about this terminology of data fabrics and data mesh capabilities. And what we're seeing is that the modern set of tools and techniques that we're deploying for data integration in order to support those data pipelines that feed the analytics and AI environments, those are all shifting towards this more distributed, metadata-driven, semantics-enabled type of environment that kind of falls under this umbrella that we call a data fabric. And so that's, again, what we're here to talk about today is how these solutions are coming together to solve modern data management challenges. One of the things that you'll see across the industry is you hear from different vendors. A lot of times when people talk about data fabric, they're really addressing only the right-hand side of this slide. They're really looking at what data fabrics mean for the analytics, AI, and data science realm. But this presents real challenges for organizations looking to finally solve this problem of more effective data management, because most of your business data is actually born on the left-hand side of this chart. Your systems of record, the applications, the APIs that are generating that operational data are generally living on the operational side, often with different teams and different organizations and different IT systems. And so you can't just assume that building a data fabric on for the analytics platforms, for the AI platforms, is going to finally solve that data challenge from an end-to-end basis. We really need to look at it in a much more comprehensive way, and that's part of what you hear me say in the next 20 minutes or so again and again, is that a data fabric solution needs to cover both the operational domains as well as the analytical domains. And to add a little bit more color to this picture. When we think about the types of operational systems that are out there, it could be microservices environments that have already been modernized around an event-driven framework. It could be monolithic applications that are operating in a more conventional three-tier layered model with large-scale monoliths, even going all the way back to most large organizations are still operating, even mainframe systems or legacy COBOL systems in some parts of the industry. We see operational databases. We call them OLTP engines, online transaction processing databases that do the operational data. We have engineered systems like the Oracle Exadata environments and others that kind of work for multi-model type deployments. And so all of these operational systems are figuratively and also literally where the data gets born. When we have whether it's devices or SaaS applications or ERP systems or e-commerce platforms that are generating data, this data is generated on the operational side, on the left-hand side. And as that data needs to move, typically it's moving towards the right-hand side of this chart into things like operational data stores or data hubs, moving the data into data lakes, data lakehouses, data marts, data warehouses. We employ virtualization solutions for querying that data. We have a variety of cloud as well as on-premises systems where we analyze this data. And with the rise of generative AI machine learning solutions, we're now also using the data lakes and the data lakehouses to train our models, to fine-tune our models, to collect data from a variety of upstream sources and work on that data. And so when we, again, reflect on why so many challenges have been there with making these solutions successful, a lot of it comes back to the problems or the challenges of getting data at the right place at the right time and where you need it. And that's where this idea of an event-driven data fabric platform comes in, where we can connect the systems and applications and data stores where the data is created, where the data is born. We can connect those systems in this mesh or fabric type architecture so that we're making it instantly available in an event-driven way for the analytics systems to consume downstream. And so that's really the concept that we're going to be exploring for the remainder of this presentation, is how we make that happen in a multi-cloud environment and what types of architectures and use cases that will empower, again, in the spirit of understanding how we can be more successful with modernizing the data platform. So, I've already delivered the punchline here. The thesis of this talk is that when we combine the benefits of an event-driven architecture with the benefits of a data fabric, we're really going to get the best of both worlds and provide what will be a very powerful solution to align that comprehensive end-to-end event-driven data fabric. So again, combining event-driven architecture with data fabric really offers the best of both worlds. We can, decouple the monoliths. We can help move towards a more modern microservices-driven architecture platform for applications. We can eliminate a lot of the batch processing that goes into the data movement architecture. And as many of you already know, event-driven architecture kind of empowers this idea of a data product and exposing it through a service interface, EDA being the mechanism for exposing event-driven data products. But data fabrics are also an important mega trend happening in the industry. And this is because data fabric really focuses on the data modeling and the data centric design first. There's a lot of focus around support for transactional consistency and maintaining ACID properties of data transactions from the time they're created to the time they're delivered in the analytics environments. A lot of emphasis around semantics and business glossaries so that we understand what the payloads are all about in terms of the business language that drives the data that we consume. And then ultimately, data fabrics are where we empower data products that are really focused on delivering value for business intelligence, for reporting solutions, for artificial intelligence, and for machine learning. And so it's pretty easy to see when you combine these two sets of architecture concepts or frameworks or ideas together, we can really solve a wider range of problems. And that's the opportunity that we're going to discuss for the remainder of this talk. The kinds of use cases that we would look to cover here, really just to put a fine point and make it very pragmatic, is if we combine the best of an EDA with the best of a data fabric, we're going to be able to cover the operational use cases as well as the analytical use cases. And so some exact or some precise examples of what that means are, application modernization, supporting IT initiatives to modernize from monolithic towards microservice or mini service architectures. So, moving those legacy monoliths into more flexible and agile architectures for going forward. We can use event-driven frameworks to support business continuity solutions as well as low downtime migrations. And then there's also for operational data, the ability to support real-time and event-driven data consolidation architecture. So being able to move those operational events into consolidated stores so that they can drive systems of engagement supporting the business. On the analytical side, there's a whole range of solutions that we can also support with the combination of EDA and data fabric. It's these multi-cloud integrations where data might be created on one cloud or even on premises, but it's analyzed in a second cloud or in a different physical data center. Being able to support these real-time architectures to do the real-time analysis is a very important attribute that many organizations are looking for. Supporting these real-time and near real-time business intelligence and reporting environments, data federation, semantic modeling, and of course the real-time transactions into those tools. And then for generative AI, machine learning, there's a range of use cases we can support, including ingestion, the lakehouse pipelines, supporting what's called retrieval augmented generation for doing or providing higher quality generative AI questions and answers using actual live business data to answer those questions. We're seeing now incredible interest across the industry in what we call agentic AI architectures or data architectures that support AI agents. And that's utilizing specific set of API technologies like async API. And then, of course, providing all this access to real-time data and real-time events is very important for organizations that are looking to do more effective model training, more effective fine-tuning of their AI models, and ultimately deploying higher quality generative AI solutions that are running on actual business data rather than on general purpose internet data. So there's a whole range of use cases that we can really support with these newer systems and architectures. I'm going to go through a couple of them one by one. For those of you that are familiar with microservices design patterns, one of the more interesting use cases up front that we can use EDA and Data Fabric to provide a better architecture pattern is around something called a transaction outbox. So in the original concept of the transaction outbox, you would have a single database transaction that contained the updates to the base tables as well as a developer provided JSON object that would then be put in an outbox table. And then you would have a message broker that periodically pulled the outbox table in order to move that payload to other subscribing services. So that's fine. This is a pattern that's been around for a long time. Some of the attributes of this, the developer writes and maintains the code to do this. It's more of a polling architecture rather than event-driven architecture. And then the payloads themselves are very coarse-grained. There's no smart filtering or smart routing on the data. It just kind of goes into a conventional queuing type environment in the base pattern. But when we think about applying an EDA and a data fabric approach to this, we can eliminate a large amount of developer coding that goes into placing these entities or these JSON objects into an outbox table by actually just dealing with them directly in the transaction log. So on the right-hand side, you'll have a service, a microservice, a mini service, or even a monolith that basically interacts with the data store through conventional get put type APIs. In this case, the data store using a feature like duality views in an Oracle database can store all the data as relational formats in a row store, but the application, the consuming application, thinks it's working with a document store. So you get a much more efficient storage mechanism, but the application gets a very easy to use get put type API. In this type of architecture, the business object or the order document actually shows up in the transaction log. Even though it's never physically stored in the tables, we can do change data capture on that physical object and then move it downstream to a smart event mesh, like we get with the Solace environments. And so with this type of pattern improvement, you can get a lot greater amount of end-to-end automation. You eliminate a bunch of coding. You've got a millisecond level event push on the architecture framework. Everything is triggered by the events of these documents arriving in transaction logs and then being moved out to the mesh environments. And then because we're using a mesh, we can do that fine-grained filtering. So any of the low-level properties and attributes can be independently subscribed to by the consuming applications, and only the data that's subscribed to is actually routed to the endpoints. So it's a lot smarter end-to-end framework, much more event driven, and low code environment on top of all that. A second use case that the EDA and data fabrics can support is around application modernization. And so for organizations that are looking to provide a phased approach towards eliminating older monolithic environments and moving towards micro or mini service environments, typically that's done through a phased decomposition of the functionality of the monolith. One way to support that is by utilizing a combination of an event-driven mesh as well as a data fabric, event-driven data fabric. And so what we can do there is keep the data tier transactions in sync with the independent microservices, as well as keeping the application business processes in sync as well. So in this way, you can, as a phased approach, begin to move module by module or functional domain by functional domain, the monolithic systems from the left over to the microservices systems on the right. And these can have different backing stores, different databases. You can shift from relational model to a document model, or even a caching or a graph architecture. And then you can also modularize the application tier. So we use the combination of this event mesh and a data fabric as a way to keep these systems in sync during what could be several months or even several years of functional decomposition to phase out the older system as businesses move towards the newer system. So this is one approach to doing application modernization that can be very effective. A third use case that EDA and Data Fabric solves is this multi-cloud transaction fabric. And so here, as I mentioned at the beginning, there's a huge imperative for many organizations that are moving towards multi-cloud environments. Again, sometimes it happens deliberately through a strategy to go multi-cloud, but other times it happens by accident. It's just something that emerges over time. For large organizations, you get one business unit that buys one cloud service, you get a second business unit that buys another, get an IT organization that maybe has some systems that need to remain on premises, and all of a sudden you need a data architecture that can work effectively in a multi-cloud environment. And so that's exactly what these EDA and data fabrics have really been designed to do from the ground up. These are distributed environments, or we call distributed architectures. They're agent-based themselves, so they have endpoints that don't require a centralized monolith in the middle to do the replication, and they work in a heterogeneous way. So heterogeneous here means they can run on different clouds, they can support different data stores, support different data lakes, different environments, and you get this ecosystem that can work in a very high speed and low latency type of way. So we can move system events, we can move device events, we can move data store events, we can move transactions, which could be transactions that are happening at the broker level, but we can also move ACID compliant transactions that are maintaining snapshot level consistency of your data stores. So that means we're supporting exact once transaction semantics, and we're able to move transactions that start on one cloud over to another cloud while preserving the transaction boundaries. So you get trusted, highly consistent data, even as it's moving between these cloud environments. Again, so that's something that you can get with this combination of an EDA or an event mesh and a data fabric combined solution. The next use case I want to talk about are event-driven data hubs. We've had this idea for decades of what we call an operational data store. But traditionally, like maybe 7, 10, 15 years ago, these were almost always ETL driven or batch driven. And with those ETL driven environments, you can get snapshot level consistency, and typically maybe you get daily updates or at best intraday updates. But as time has marched forward, what we're seeing is the business demands really have shifted towards requiring more and more real-time solutions for these data hubs, whether it's a customer data hub, finance data hub. I call these on this chart domain-specific data hubs, where the data hub is about a specific type of data. But there's other types of data hubs out there. We could have retrieval augmented generation data hubs that combine vector data and application data in order to support generative AI use cases. You can have more conventional operational data stores where it's a mix of domains coming together for aggregating data from different upstream applications. More and more organizations are looking at time travel use cases for the purposes of audit and compliance, being able to look backwards in time at specific points to see what the data said at that point in time historically to fulfill an audit or a compliance requirement. And then we even see organizations creating data hub type solutions within lakehouses using open table formats like Iceberg, for example, in order to support these ODS use cases. And what we have in common across all those different kinds of data hubs are that organizations increasingly want them to be lower and lower latency, right? It's no longer good enough to have data that's fresh as of the last day or even as of the last, 4 hours or 6 hours. People want the data in these data hubs to be up to the moment, fresh within the last couple of seconds or the last couple of milliseconds. And that's where these event-driven architectures can really come in and help out with that. So when we look at a multi-cloud data fabric and event mesh type solution, we're able to do change data capture, event capture on the source systems, and then drive those events in real time at a millisecond level latency into the data hubs. And again, whether that's a vector data hub, a relational data hub, a columnar data hub, an Iceberg data hub for a data lakehouse, variety of different systems and solutions we can support with these tools and technologies. Then that leads us, this discussion of lakehouses leads us into this type of modern architecture that we're seeing for an end-to-end event-driven lakehouse. And so for these solutions, the data flow may start on the left-hand side of this chart with your operational workloads where transactions are created, events are created, and then what we see is sort of those events and those data transactions being driven into the lakehouse and then actually through the lakehouse as well. So event-driven architecture doesn't just exist outside of the lakehouse. It also includes the streaming architectures within the lakehouse as well. And so this type of end-to-end architecture can support data analytics on let's say, a cloud optimized data warehouse. It can support operational reporting on the cleansed and raw data that's deployed within a lakehouse. And we can also support the AI agents and the application use cases that need to consume the events directly from the operational systems. And so this end-to-end multi-cloud event-driven data fabric has the ability to support those types of architectures as well. And I think the last one that I'm second to last one that I'm mentioning here is around agentic AI and the event-driven data fabric. And this is where we're really using events that are created by devices and data stores and applications in order to support agent-based activities that are then consumed by human users as well as by machine users. And so as we see the rise of these agent meshes where the agents talk to each other in order to fulfill some task, one of the things that these agents are going to make use of are the event-driven APIs. And these event-driven APIs that are empowered by the async API specification can provide very high degrees of automation around how they connect, attach, and discover what data and events are behind those APIs. And so tools and technologies like the Solus PubSub environment, like the Oracle Golden Gate environments, each support async API directly. They work together through a pluggable interface, and that means you can have these modern agent type interactions for AI going directly against the event-driven architecture and also directly against the event-driven data fabrics. All right, and then last but certainly not least, these retrieval augmented generation use cases are very important. I'm going to speed through this one a little bit. Many of you have already heard about what a RAG solution looks like. It's essentially the idea that you've got a human user that asks a question. That question is first answered through what we call a semantic search using a vector data store. And then the data that's retrieved from the semantic query is then passed in through what we call an augmented prompt or prompt engineering into the GPT engine. And this is how we get more reliable, more fresh data from the answers that we get out of these GPT engines. The benefit of an event-driven or an EDA-driven data fabric here is that we can use real-time events and real-time data in order to answer questions from these GPT engines. And so as the data is being loaded into the vector store, we're generating the vector embeddings. Those vector embeddings are created in real time and used to answer that initial similarity search. And then ultimately, the actual business data is used in the prompt engineering stage to drive more reliable answers from the GPT engine. So that's how this would work with a multi-cloud event-driven data fabric. All of this is empowered through a new integration that we've made from Golden Gate to the Solus PubSub Plus environment. This isn't going to be a marketing talk about that particular integration, but we wanted to make you aware that this is a feature that we've recently rolled out between Solus and Oracle Golden Gate. It's a pre-built micro integration that allows us to align the events coming from the data fabric environments into the event mesh. We can empower a lot of the use cases we just discussed. Please feel free to follow up with that for more information. When we look at how this scales out on a global basis, we really do see this future being very bright around what we call a planet scale event mesh, where we're driving data fabric use cases that can work across domains and data centers. It could be any cloud environment, Oracle Cloud, AWS Cloud, Google Cloud, Azure Cloud. It could be your on-premises environments. And we can create this planet-sized framework for doing event mesh and data fabric use cases at great scale. So again, just to wrap up, the combination of an event-driven architecture with the data fabric architecture empowers all these fantastic new capabilities. I think the future is very bright with supporting these data modernization use cases. Again, the challenges around delivering ROI for these AI and data analytic use cases, I think will get better as organizations begin to align their event-driven architecture practices with their data fabric practices. We're going to see a lot of improvement around those use cases. If you're interested in more, please feel free to take a look. We've got some interesting blogs about the Golden Gate and Solus micro integration, and then you can learn more about Golden Gate from any of these links. So with that, I think I'm out of time. I'll go ahead and wrap up, and I just want to say thank you, everyone, for your attention today. I hope this was interesting for you to listen into. Take care, and see you later.